Hello everyone, welcome back again. My name is Jesse, and in this wonderful tutorial, we're trying to do test summarization with SpaCy. So how do you summarize your test? How do you summarize your document with SpaCy? So test summarization is the process of just finding the most important information about a particular document, right? Just summarizing a particular set. So the main idea for doing test summarization is, first of all, you're going to remove unnecessary words, remove all the noise by removing the stop words and then the punctuations. And I'm going to build a frequency table of all the words, right? The word frequency distribution. So how many times each of the words appear in a document, and then you are going to compare the number of times the word appear in a document to that of a sentence. Then I'm going to score each and every of the sentence. Then later on you build them together, right? By joining them. Now let's see how to do that. So I'm just going to import this particular package. So import SpaCy. Then from SpaCy language, you're going to import the stop words from SpaCy, and then you're going to also import punctuation. That is if you're going to use it. So you can omit this one if you want. Okay, now let's see how to do that. So this is our first test, our first document, and then this is going to be our second document. Now the main idea is that we are first of all supposed to normalize the words by removing stop words. So let's see, and then tokenize them, right? So let's see how to do that in SpaCy. So in SpaCy, just going to build a list of my stop words. So I'm going to call it as stop words. It's going to be a list of all the stop words, right? So stop, it's going to be stop words. So if I check for this, my stop words here, I have a list of all my stop words, which is about 305. If I check with the length of this, let's call that the length of this my particular stop words. We have it as 305, right? Okay, so that's all the stop words. Now we need to be able to find a means of tokenizing our entire stuff. So in tokenization, it's going to be like this. So the normal way is going to build a simple NLP object. It's going to be our doc. Let's call that NLP. It's going to be SpaCy dot load here, right? To build a simple NLP object, I'm going to build our docs. So docs is going to be an NLP that we have, and I'm going to apply my document 1. Perfect. So to build a token of all the words, just go with the normal way of, let's say, my tokens. It's going to be for word or for token in my doc, right? That's how to do that. So print my token.test. So that is how to do that. So let's see that one first hand with this, down this one. Okay, so just build a list of all the words, all the tokens in this particular step. So we're going to use this same particular step to build our list of tokens, right? And then build our word frequency. That is the next step you're going to do. So let's see how to build our word frequency. So it's going to be like, so how do we build our word frequency? So our word frequency table is going to be a dictionary of all the words and their counts, and then words that are not stop words. That is why we created a list of stop words here. Okay, so now let's see how to do that. So it's going to be like this. So word frequency, our word frequencies, right? And I'm going to build a dictionary of it. So it's going to be, you can make it like this, the normal Python way of creating a dictionary, or can just go with the simple format of this. That's going to be a dictionary, an empty dictionary. Then I'm going to loop through all the words. So for word in my docs that I have, if that particular word, right, dot test, because realize that to create a token here, you just go with dot test for that particular word here. So if that word dot test, that is the word that is found in the token, is not in our stop words, then if that word is not in the stop words, then if that word also is not dot test is not in our word frequency. If it's not in our word frequency dot keys, then I want you to add it to it, right? If it's not, so the first thing is that we are trying to find all the words that are not stop words, and then we are going to put them inside our dictionary and then count the frequency of those words. So it's going to be our word frequency, then our word dot test. We are putting them inside as 1. So that's going to be the first appearance of that word if the word does not exist, right? Now if the word exists, so else going to be here. So if the word exists, then I want you to do another step. So going to be word frequency dot the word dot test plus is equal to 1. We are just going to add it to it to keep on updating it. If I run this here, now it's working perfectly well. So if I go back and I check my word frequency, you're going to see that it's having machine 4, learning 8, this comma comma. So that's why sometimes you can use the punctuations to remove all these unnecessary words from it, right? So steady appears 3 times and all of these things. So we have been able to build a word frequency of it. Okay. Now the next thing is that sometimes if the word is longer, if the sentence is longer, right, it may have some bias. If the sentence is short, it's going to have some bias. So you need to be able to find the maximum frequency for each and every of them. So how do we go about with that? So I'm just going to go with this. So that is how to do that. We're going to find the weighted frequency of them, right, by comparing them to the most occurring word. So to find the most occurring word, I'm going to go with maximum frequency, and I'm going to use the normal Python function of max, then our word frequency. Our word frequencies dot values. Perfect. So if I check for the maximum frequency of this, it may be around 9. Right, 9. Okay, perfect. So now we're going to find an average of all of them to get our weighted frequency by dividing them each word over the most occurring frequency. So it's going to be for word in our word frequency. Then it's going to be our word frequency, that is individual words of them. We're going to find an average of it. So it's going to be our word frequency of the word, each and every of the word, divided by the maximum frequency. Okay. Now if I go back to this my word frequency now, so that has changed, right? So we realize that from here, when we had it here, we had machine 4, learning 8, but when we come to the weighted one, we are having totally different, right? 0.4. So it's comparing each and every of these words to the most occurring word inside this particular document. Perfect. Now let's move on to our sentence tokenization. How do we tokenize our sentence? How do we create our sentence score? Because every sentence have words, so we must compare the frequency of each and every of the words that occur in each and every of the sentence to be able to find the sentence scores. So you're scoring every sentence based on the number of tokens or words that are not stop words. So let's see how to do that. So first of all, to create a sentence token, it's going to go with our normal way of creating a sentence token. But let's move straight away to a list comprehension. So sentence, a list comprehension already, and then it's going to be our sentence. For sentence in, I don't know whether it's the sentence. Okay, spelling is correct. Docs.sense, right? So it's going to create our sentence list for us, which is quite interesting. Now we need to be able to find the score, right? You need to find the score. We are going to score each and every of the sentence based on the number of words. So how do we do that? You're going to do it in the same format as we did here, as like how we did this format. That's the same thing we're trying to apply here, same principle. So I'm just going to create a sentence score dictionary with sentence scores dictionary, and I'm going to loop through it. So for sentence in my sentence list, I'm going to look through it and see if any word exists, my word in sense, if that word dot test. So we're going to tokenize all of them and then normalize them, right? The dot test is SpaCy's method of tokenizing them. Dot lower is we are trying to normalize a word, right? So that we see the same as see all the words which are even uppercase, title case as together in our word frequency dot keys. So we are looping through our word frequency keys, normalizing them and comparing them to our main sentence. Sorry for the noise. So if that is the case, then I want to find the length of it, sent right of my test dot split. Sorry for the noise. Then you can set it at a number. So the number of sentences can be 20, it can be 30, it can be 25, any of them. Then it's going to be if our sentence is not in our sentence scores dot keys, right? Then I want you to do something. Then we're going to create a sentence call. So sentence, I'm going to add it to it. Where.test.lower. So that's the basic idea to it. Else, that's if the word exists. Fine, if the word does not exist, then append it to it or update it. So we're going to update it or append it to it. Perfect. So now if I go back to our sentence course here, so sentence course, so that's is scoring them, right? So machine learning, this sentence is 4.5, then machine learning is closely related is 4.1, and then this machine learning algorithm is 7.33. That is how it's scoring them. Now that is one way. We are done. We are almost done. So we need to find the top n. Need to find the top n sentence with the largest score. So from these two ones, we had 7.3 as the highest. We have 4.5 as another high. So we are trying to structure them in such a way that the highest one is going to come before the least one. That is why we need this particular package. So we're going with this package to find the top n sentence with the largest score. So it's going to be our summarize test, summarize sentences. It's going to be our n largest. So we can find the n largest. We can find the 5 or top 5 or top 7 or top number, any number. It can be 6, it can be 7, it can be any number, right? So let's make it 7. Then I'm going to supply my sentence course that I had. Then I'm going to set the key as my sentence scores. So if I go back to this tab we had here, our summarize test, you see that now if you compare it with the, let's reduce it so that you see what I mean. If you compare this one here, which was 7.33, right? Machine learning algorithm built a mathematical model of sample data. That is the first one that is appearing because that is the highest one. So machine learning algorithm built a mathematical model of, and then the next one follows like that. So you have able to finish it. And next thing that you must be able to combine them together because this is a list comprehension. So how do we do that? Because this one is in the format of a SpaCy span, we need to convert it to text string to be able to allow us to do that. So we just go with this format of creating a simple final test. So final, convert it to test right string. So w.test for w in or for word, right? Summarize sentence. So that now it is in a perfect format that you can join them. So now let's join our sentence together. So it's going to be like this. Our summary is now going to be we're going to join them. So dot join, then our final sentence. If I go back to my summary now, perfect. So now we have our summary. Pretty very interesting. If I check for the length of the previous content, which was document 1, we had 1600. If I check for the current one that we had, which is summary, we have 804. That is that's reduced over 200, right, from minus 200, which is very interesting. So that's how to create a test summarization with SpaCy. So you can put all of these things inside a particular function, right? You can put all of them inside a particular function and run it over and over again. So then let's see that. So I've done that here with this here. So that's the same stuff that we had. So I'll just place the entire stuff inside a function, which is quite simple. The code will be below, and then you can run it straight away. So let's see how it's done. I'm going to import it. Let's paste it here. So that's the entire stuff here. So the main idea is that we are going to import all our packages from here, and are going to build a stop word. We filter them out. We find the frequency of the words here. Then we find the maximum frequency to get the weighted frequency with this. Then we build a sentence token. Then we do the same stuff for building a dictionary of all the sentences by comparing each and every of the word to each and every of the sentence. Then we're going to find the largest score, then convert them to strings, then join them together. Right, that is the basic idea for this particular stuff. So let's see our final example. So from SpaCy, that is the same code here, is the same thing I've done because I've placed inside this particular stuff here. So let's see an example. So I'm going to go with the test summarizer. I'm going to paste in our first document, which was our second document, so document 2, which is this document, right? Let's put it here, document 2, which is our father, right? The Lord's Prayer. So if I go with this, let's see how it's going to reduce it. Wow, so this is going to be the original document, and then which is 2,285, and then the current document is 115. So that's how to create a simple test summarization with SpaCy. I want to do some interesting stuff. We want to try and check this summary that you have done with another package, right? So this is going to be with Jensen Summarizer. I'm going to be using that one to check it and see whether it's going to work. See the difference. So from Jensen, right? Import summarize. So now let's see whether it's going to give us something better. So let's go documents. Okay, wow. So from document 1, see that Jensen Summarizer gave it a very short summary, which is quite interesting. And you see that this summary here is almost similar to the summary we had here, right? Just the first part of it. That's exactly what Jensen did. So thank you for watching. In case you have any question or contribution, you can just put that in the comment section so everyone can benefit. And please don't forget to subscribe. Stay blessed.